Hello, and welcome to another session, actually the closing session for the Wikidata module in the course at Tel Aviv University from Web 2 to Web 3, from Wikipedia to Wikidata. And I'm very excited today to host Denny Vrandečić with us. This has become a small tradition. We have Danny joining us for the second or third time, I can't remember now, talking about, I think, one of his favorite topics, which is Wikidata, and more specifically, abstract Wikipedia and Wikifunctions and all that, and hoping to A, make some order for people about all these different terms, and B, hopefully hear from Denny what the recent changes and updates on the projects are. But let's begin at the beginning. Denny, why don't you please introduce yourselves to the students and to maybe the audience who's looking at this and may not know who you are.
Thank you very much for having me. As usual, it's a great pleasure. I'm Denny Vrandečić. I joined the Wikimedia Foundation now almost 2 years ago to work on the abstract Wikipedia project, to work on Wikifunctions. And previously I've been at Wikimedia Deutschland back in 2012, 13, where I was working on Wikidata. And yeah, I'm super happy to talk about those projects and to see where we can develop them together.
So you're being modest as always, but you've been one of the originators of Wikidata, if people are hearing this for the first time. And this has made tremendous changes to the way that we do wiki work in general, and to, in a sense, realize a long-time dream of people like Tim Berners-Lee, who wanted to create a semantic web. And I think Wikidata was an important step in the right direction. So maybe we can start by you sharing a bit of what is the semantic web, why is it important, why you started Wikidata, and from there we can progress to why an extra step beyond Wikidata was even necessary.
Yes, thank you. The whole idea about Wikidata also started actually when I was a PhD student in Karlsruhe. I was doing my PhD topic on the topic of the semantic web, and me and another colleague, Markus Krötsch, we were both very active Wikipedians, and we loved it. This was in 2005. I joined the KIT, the Karlsruhe Institute of Technology, in 2004, 2005. And then there was the call for the very first Wikimania in Frankfurt back then. And we were like, oh, let's try to submit something for that. And we were like, what could we do? And it's like, oh, well, we like Wikipedia, we're doing semantic web research. What would happen if we bring those two things together? So the semantic web was a vision that originated with Tim Berners-Lee, the founder of the web. And he was talking about this since the 90s, and then wrote this article in 2001 together with Jim Handler and Ora Lassila. And the basic idea of the semantic web is that we don't have just a web for human users, for us to see and read the web, but also to have machine readable data on the web, so that your browser or your agent can actually take this data and do stuff with it. The original vision in Tim Berners-Lee's article, for example, was describing that your dentist would have their website, and there they would have their opening times, their contact address, their information about the insurances that they take, and so on, all this kind of information in a machine readable format, so that your agent on your behalf could check your calendar, could check the opening times of the dentist, and see what kind of and find then time, for example, to get you an appointment at the dentist. Or it would take also into account the location, which would also be machine readable, and your location and what your previous appointment is, and they also get you how do you get from one place to the other. And it was getting quite complicated and do all these things. But basically you would have the machine could do a lot of things and help you, and we're still far away actually from having this idea realized, right? But having machine-readable data on the web was one of the main goals here to run this thing. Yeah. So Wikipedia started also in 2001, just like just when the paper about the semantic web was published, and had a very different trajectory. Right? We had this idea of creating an encyclopedia that anyone can edit, that anyone can read. And back then it was just like this crazy idea done by a small number of people working towards it. But already in 2004, 2005, the trajectory was showing that we were on the right track. We had a lot of articles in a number of languages, and it was only starting that we were getting to many, many languages back then. And it was already visible that Wikipedia isn't just a great encyclopedia, but also it would become potentially a very important knowledge base for all kinds of artificial intelligence applications. And Wikipedia has this emergent, it wasn't planned, right? But it has this great feature that it describes a lot of topics of interests. And today we are in a situation that there are Wikipedia articles about 20 million different topics across the 300 languages that we have. And in Wikidata, we have kind of a machine-readable backbone to support the different Wikipedia language editions, so that we know like what are the articles about, and to have some of the structured data about those topics in place. So if we have then, for example, a Wikipedia article about a city or a person, Wikidata could have the information about the geolocation of that city, about the population of that city, in which country it is located, or about a person, like the date of birth, the place of birth, the occupation, and this kind of basic structured metadata about the topics that Wikipedia articles are about. And then taking it from there, for Wikipedia itself, you can have the major benefit that this structured metadata can be stored in a single place and can be displayed in the different language editions of Wikipedia, so that you have to edit it only once and maintain it only once, and therefore reduce the cost of creating and maintaining Wikipedia considerably across the languages. So sorry for this long answer, but this was like taking us from Tim Berners-Lee's idea of the semantic web and how this was applied to Wikipedia. And still today, Wikipedia and now Wikidata are a major part of this whole semantic web vision, because it provides us with a large vocabulary of topics of interest, or things of interest, so that everyone can refer to a country or a city, or even an idea like democracy or freedom by referring to a Wikidata identifier, and then we know that we're talking about roughly the same thing. Obviously, we're all talking about different things, and we're talking about democracy, but it's sufficiently close enough, for example, to index a library or to index a book or a movie with those topics.
Yes, indeed, and I think one of the strengths has been the ability, of course, to, again, for those who may be just starting out hearing these terms for the first time and trying to make sense of all of it, one of the strengths of Wikidata is, of course, the ability to query it, to ask questions that are very specific and get very specific answers that before, search engines like Google would not be able to give us answer to, or rather would give us a list of sites rather than giving us specific answers to what we are really looking for. And the annoying thing, I guess, for people who started it like you, was that the information is floating somewhere in there in Wikipedia, but is not really being accessible. So in a sense, this was a way for humanity to try to make use of data in a way that can that humans can use it and machines can use it as well. And I know that besides, being able to query and visualize the information, which is a huge deal that Wikidata is allowing us, right? We can not only ask who all the women physicists are, but we can also actually see them on a timeline or see them on a map, and that changes the interaction between humans and knowledge and how we learn, how we are able to actually consume information. So that has been a huge shift. It also allowed us two more things, actually, because we do have categories in Wikipedia, but we were not able to the moment we wanted more than just physicists, right? But we wanted women physicists who were born, I don't know, in Lyon between specific years. So when we want to shrink down or to be more specific, again, categories won't give us what we need. And so it was necessary to structure more of the data in Wikipedia. And I think the last thing that is quite important is all the identifier part, right? But our ability to aggregate or collect or converge to be like a hub of metadata for different other online resources, online databases, and connect all of them together in one place. So Wikidata has helped us do all of that, which is quite amazing. But still, a few years back, here we were, and we suddenly started hearing you speak about abstract Wikipedia and WikiLambda at some point. Then it was renamed Wikifunctions. Let's talk about why that was needed. What was missing from Wikidata that made you want to do more and want to actually open a new sister project? So let's start there, and we'll continue.
I come to that in a second. I just want to add 2 or 3 things to the very good points that you made. So indeed, in our 2005 talk on which you called back semantic Wikipedia back then, when we first were introducing this idea of Wikidata, our example was actually like, what is the world's largest city with a female mayor? And this is some information that was obviously in Wikipedia, right? I mean, you had the text, you could read about all the cities, you could find the largest cities, and you could go from one to the other and see, oh, who is the mayor and what is the gender. So you could go do that go one by one and do this, but you would have to do this manually. Today with Wikidata, you can actually just ask the query, and it would give you the result, and you can then use this result to visualize it on a map. You can use it to make a bar graph automatically out of it without any line of coding or whatever. So this is one of the goals that we were stating initially with Wikidata, and that today is completely realized. We can do this kind of queries and have these answers, and much more like these. And then what I also really liked was your point about the different identifiers. So Wikidata has become a veritable Rosetta Stone of different identifiers. We are connecting to more than 7,000 different authority databases and other providers of identity, and saying, oh, this thing in this authority database, oh, that's the same thing as what is over there. And we're connecting to national libraries, to big museums, to journalistic databases, to official databases for different scientific endeavors, like in genetics or in climatology and things like that. We'll always say, oh, what we have here is the same thing, or it's very similar to that thing over here. And therefore connecting all these different databases also to each other, which haven't been connected before. And more and more of these databases actually taking an active role to the curation of those identifiers on Wikidata. So this means they are actually looking on what is the claim of those connections, can they improve on this, and they're finding errors in their own data as well, based on the fact that we are connecting now also to the different databases. And so we can get an kind of a triangulation of knowledge between what all these different databases are claiming about the same topic. So I think this role of being a central hub of identity on the web and in the whole knowledge sphere is actually a very, very important role. And I'm very glad that you're mentioning it, because this allows everyone basically to connect and to plug in their individual knowledge bases into a bigger, wider system. And I'm not saying, you should trust what Wikidata is saying blindly. That's not the idea at all. But rather that we are providing a place where people can come together with their databases, where they can connect their knowledge bases and thus have this large federated space of knowledge where everyone can now contribute. And you obviously shouldn't be trusting in Wikidata because anyone can edit it. So you should be trusting the
references, actually.
And look it up if it's actually correct what we're claiming, and see, and then you can say, oh, I do trust the National Library of my country, or I don't. Well, I mean, it's up to you, but but you certainly don't have to put any trust into Wikidata and its process, or you can. It's really up to you in the end, and to decide those things.
Yeah, I think one of the things that I always show my students is that Wikidata is also helping us curate different points of view, just like in a Wikipedia article, right? So if, for instance, we have different sources on, like external sources, saying that someone was born on a specific date, which happened to me just yesterday with a student, right? They wrote a Wikipedia article, and I said, okay, let's go to the Wikidata item to update it as well. And we found out that there were two different dates where that personality was born. And so I said, okay, then in this case, we don't have to judge ourselves. Wikidata can in a sense, host these different sources, and we can bring a link to everything. So at the end, it goes to the user and how we are smart consumers of information online. But I think this brings me to some other thing that you kind of mentioned in one of our previous conversations, and that is Wikidata cannot be the only thing. In order to create a semantic web, it actually needs to be a web of, right, of different sites working like that. And in a sense, Wikidata was a game changer because it's so big that it kind of created a space for more of it. And we now have, or we see the beginning of Wikibase, which we're hoping will catch on. But how do you see this growing, this network of different semantic web platforms operating today? And then we can touch on some other challenges that we have with Wikidata. But I'm just curious to know if, now we are recording now in May 2022, and I'm curious what has changed in that sense.
It has always been clear that Wikidata can't be the only place that has the search data. You want to have everything in Wikidata. We are not built for this kind of scalability. We can't actually host all the information in the world. One example is, for example, the data about bibliographic metadata. There are, I don't know, 200, 300 million papers out there, something like that. I don't know what the current estimate is on this. Publications, scientific publications, they're in the hundreds of millions. And having them all in Wikidata might be possible, but it would be really a stretch of our infrastructure. But then, for example, I don't know, there are millions or maybe billions of stars out there that have a name and so on. Do we want to have all of them in Wikidata? This would really push our limitations. And it's also, is this kind of data that we really need humans to edit individually, or is this something that is better in a different system and with different ways to manipulate and edit the data? So there are certain data sets which are partially in Wikidata, and then can point out to the larger web with more federated knowledge. And we definitely want to get to a world where it's easy to federate across those different data sets. And this takes us not completely back to Tim Berners-Lee's vision, but it takes us certainly to a world with more of those databases which are interconnected with each other. And you can have different processes around the data, how it's being published, about how trustworthy the data is, about how complete the data is. Because for some data, I mean, let's say that the US Census has recently published the 1950 data. If they want to publish about every single person in the United States who lived in the 1950s, those are hundreds of millions of people with I don't know, with billions of facts about them, I guess. And having that published all in Wikidata would completely overwhelm us. And also, I mean, this would basically create a data set that's larger than Wikidata just about the 1950s United States. And it's also something that we definitely don't want to go and edit, right? I mean, we don't want to go and change this fact, because this is the fact how it's published by the US Census. We want to be able to connect those things with each other, but we certainly don't want to integrate it all in a single data set, unless you regard as a single data set the whole web. And eventually, we would really like to be in a space where Tim Berners-Lee, so that every dentist has their own website where they can control what their opening times is. This is something that they really know and should be publishing, right? You shouldn't be publishing that in a Wikidata page where anyone can go and click and edit and change the opening times for the dentist. This would be weird, right? That's something that dentists themselves should be controlling, that they should have on their website, their contact data, their insurance information that they accept, their opening times, and so on. And this is then eventually where Tim Berners-Lee was taking us, to a very decentralized web where everyone publishes their own data and where they can say anything about everyone. And then we have to figure out how to go and trust and bring this data together. The world has got,
this is of course also the answer to people who think that Wikidata is too central, right? Because it really is decentralized, and it's sometimes hard for people to grasp why. So maybe you can say a bit more about that point.
Yeah, I do agree that Wikidata is central, and it is actually too central. I would prefer if we had more decentralized knowledge bases out there. But on the other side, yes, the infrastructure is central. Like, we have the server in one place, but Wikidata has more than 400,000 contributors. This is a huge number, you know. It's like and they're working without central planning. This is like, you know, this is like a huge team. I know it's like everyone does a little bit. Some people do a lot. Some people just do like a single change or whatever. But overall together, this is a very decentralized and organic growth of people who are working with things. And with those 400,000 contributors, they're creating this set. And nevertheless, I agree with you, it's too central. We shouldn't be creating all this data only in Wikidata. People should be publishing their data on their own way. Unfortunately, we went into a world where more and more of the infrastructure on the web has become centralized, right? It has been centralized with a small number of contributors. More and more restaurants and other places that I know don't publish their opening times on the web at all. They publish it on the Facebook page or on the Grubhub page or whatever they have, right? I mean, it's in a small number of services that then kind of republish this kind of information. And often those pages don't provide the data in a machine-readable way. They actually provide it in a way that is consumable by a human if they actually come to this page, but hard to figure out for a machine. And there is no big incentive for those big republishers, you know, to publish this data in an easy machine-readable way. Because why wouldn't the people come to their websites if it was actually accessible in a machine-readable way? Whereas if you're publishing the data by yourself, well, you want this data to be as widely spread as possible, right? You don't care if people are coming to your website. You care if people are coming to your store or your restaurant or your dental practice. Publishing the data is not what you're doing. But if we have those middle, those providers in the middle that are suddenly intermediating between you as the original data publisher and the world outside. For them, the data is the main reason of existence. And suddenly they don't want you to, they don't want to share your data with the wider world. They want people to come to their websites to see your data. They want to be the intermediary in this case. So this is this is not exactly aligned with Tim Berners-Lee's vision, which is a much more distributed world where everyone actually is in control of their own data, and there are many, many different ways this data can flow into the world.
So in a sense, we've touched by now, well, we've said, and I think rightly so, that Wikidata was and still is, in a sense, a game changer, because it's showcasing that it is possible to do it. But there has been various challenges. One is scale, as you said. Even though it's the biggest semantic platform, we start to see the limits of it. There has been issues with completeness, with referencing, right? Like, how do we know where the data comes from? Is it reliable? Actually, these are similar issues than the ones that we know from Wikipedia, actually, and from working on the web in general. And these are still good challenges to try to tackle. But there has been some others, like how do we model more consistently the data, because that affects the query results, that affects what machines can actually give us as answers when we ask these specific questions, and so on and so forth. And I think, you know, looking at the phenomenon and actually trying to research it as well, which I've tried to do in the past few years from afar a bit, it looks as if the community is maturing and things are progressing, but there are still limitations. And I think I'm stressing this only to say that I believe that the next step to help us grow and expand and go beyond what Wikidata, the amazing things that Wikidata has allowed us, some more things are needed, right? There are some capabilities that are inherently missing. And I think you've laid it out so wonderfully in our previous talk by saying, look, if you take the case of Marie Curie, right, who won 2 Nobel Prizes, it would be very clear when you go to the Wikipedia entry on her, because, you know, that would specifically state how unique that is. But when you go to Wikidata, well, you'll see the information. There is no way for the platform right now to highlight this specific statement compared to other statements or to other pieces of data, right? To other pieces of data that we find in a specific item that is described. So I think that was a good example to explain that there are some limitations, but I wonder if now, you know, working on it for some time, you can elaborate a bit on the challenges that actually brought about abstract Wikipedia, etc.
Yes. So Wikidata, as we have discussed, has all this structured data and makes it available. But when a human goes to Wikipedia and has information, and they want to learn about a certain topic, structured data is never sufficient, right? It's just not. It's not that you want to see tables and tables of data and then you gain insights from it. That's not how we work. How humans work is that we are reading the articles, that we are following the narrative in the article, that we are looking for specific facts that don't necessarily fit into the expressivity of simple knowledge base of a knowledge graph like Wikidata. And the example here that you've given is, yeah, they were saying that Marie Curie is the only person who have ever received 2 Nobel Prizes in 2 different scientific fields. And that's an information that is implicitly inside of Wikidata. We know about every single Nobel Prize winner, and we know about what prizes they won, in which fields, you know, when they won it, and all of this information is there. But the explicit fact wouldn't be there. We can ask for all the people who have received Nobel Prize in 2 different fields, and we would get a single one answer, that's Marie Curie. An even simpler example is, and you'll find it on every article about the planet Jupiter, for example. It says it is the largest planet in the solar system. And this is correct, and this is, but it's not in Wikidata. In Wikidata, we would have the information about all the planets, we would have the sizes, and we could see, oh, well, the largest one is Jupiter. But the explicit sentence, that Jupiter is the largest planet, even though it's available on every single Wikipedia article in every language of Jupiter, it wouldn't be explicit in Wikidata. So in abstract Wikipedia, we are trying to tackle this very hard problem of the lacking expressivity that Wikidata has in order to bring in more information from the natural language as it is currently expressed to a structured format, so that make it accessible to more people by having it in a structured format, which can then be translated back in the natural language in order to make it readable by the users. So what we're really aiming for is to have much more knowledge, and not just the knowledge itself. Like Wikipedia is not just like a selection of facts, right? It's actually telling that in an order. It's giving you information in a way that you as a human reader can actually digest it. And so for abstract Wikipedia, we're trying to capture this digestible order. We're trying to capture the facts in the way that they are understandable and readable. You would rarely want, for example, an article that says, well, this is Sweden. Sweden has a population of 10,700,000 free and so on. But you would like to know, for example, oh, Sweden is the largest Scandinavian country with, and it's the only one with more than 10 million people. This fact wouldn't be again in Wikidata, not explicitly. It would be implicitly there, but and all this implicitness is what we're lacking. So abstract Wikipedia's goal is really to capture those implicit facts, to capture those redundancies, to capture narrative, and to make it in a way that's independent from the natural languages, so that we can then make it again accessible for the different natural languages without having to write it explicitly in each of those languages. So our goal is really to create a common baseline of knowledge that is available in every language of Wikipedia and that can be edited through every language in Wikipedia, so that everyone can contribute to this common baseline of knowledge and make it available in all those languages. So this is really what we're trying to do with abstract Wikipedia, to increase the expressivity by a lot of what can be said in Wikidata.
So to expand the expressivity of structured data, right? So in a sense, trying to have more of what we see on Wikipedia, which is usually telling a story in a narrative, human understandable way, in a structured way, right? And that would tackle also the issue of smaller languages, right? I mean, it has so many implications that I'm sure you'll touch on a bit later on. But if I understand you correctly, that's the idea behind abstract Wikipedia. Abstract in the sense that we are going to take some facts that until now we could not, structure on Wikidata, and in a sense structure more parts of it. And that would allow more translation, more automated translation, more creation of articles or bigger parts of articles, right? In an easier way, so that human volunteers can then fill in the gaps for the portions that are not structured, or edit the structured parts, but still, have some more parts of the articles on Wikipedia structured. So if that's abstract Wikipedia and that's the main idea, what is WikiLambda and what is Wikifunctions, and why do we need two of them?
So we, as usual, not very good at naming things, but WikiLambda is just the name of the software that is running on the new project called Wikifunctions. Wikifunctions will be a large library of functions. And a function, It's basically anything that takes in some inputs and returns you an output. And we will use Wikifunctions, for example, for simple functions like, okay, we have a date of birth for a person, for example, and we want to know how old the person is right now. So we could have just, a function that calculates exactly that, like how old is a person at a specific on a specific date. And this is something that the Wikipedias currently already do. They provide you with information like this person was born then and is now 74 years old or whatever. And this is something that is available to the larger Wikipedias, but not that all Wikipedias have that, because in fact this function that calculates the age has to be encoded in each of the different Wikipedias individually. So if you want to have this capability of being able to tell the age of a person based on the date of birth, you have to actually rewrite and recreate this function in all these different languages. And if something in this thing is in this function calculation is wrong, for example, you got the leap year is wrong or whatever, but you have to fix it in all of the different languages because it's all individually created. So this is a lot of work that is repetitive, and it needs a specific skill which might be rare in a given language. So what we're trying to do with Wikifunctions is basically to centralize those functions in one place, so that all Wikipedias can call this function now just from Wikifunctions, and they don't have to repeat it, and they don't have to maintain it themselves and keep it up to date, which will hopefully also lead to many more functions being available. We can think about functions, for example, that take a geoshape and calculate the size and see if it's actually if the data is correct there, or to calculate the density or population density from our own data, and so on. There are many, many functions that can be helpful in Wikipedia. One set of functions are the natural language generation functions. So given a structure, and it can be a super simple structure, like for example, you have the country and the population number, right? Given a structure like this, create a sentence that represents the fact in a given language. And this would look differently from language to language, obviously. So if you have something like a simple Wikidata triple like saying, Marie Curie was born on this date. Okay, so now take this Wikidata statement and turn it into a sentence. This could be a function in Wikifunctions. And this function then could be available in Polish, in French, in English, in Hebrew, and then we can create from a common set of facts, we can create articles in all those different languages. So the idea is then that, and then with Abstract Wikipedia, being able to express more complex information that is currently not expressible in Wikidata, being able to express the narratives, we come to a world where the content of each article is being maintained and created independently of the natural language, so that abstracting from a natural language is where the word Abstract Wikipedia comes from, so that we can maintain each content only once, and then we have to have this set of functions for every language only once, but keep and maintain those things independently, and when we then apply them to each other, we suddenly make this abstract content available in all those languages that we have those functions for, that we have the natural language generation functions for. So we are really reducing the cost of Wikipedia massively, because instead of having 1 million articles in 300 languages, and you have to maintain and create 300 million articles in those different languages. What we instead do is, well, we have this abstract content of 1 million topics, and it's maintained only once. So it's only so the cost of this is only like 1 million topics, and then for the 300 languages, we have to maintain the different visualizers, the ones that create the actual natural language. We call them renderers, but the cost is suddenly much, much lower than it was if we would have created all those articles independently and kept them up to date independently. Because instead of multiplication of the number of languages that we want to support and the number of topics that we want to have knowledge about, we turn this multiplication into an addition. So and this reduces the overall cost of Wikipedia to a space that we actually know that we can deal with, because we know that the English Wikipedia has 6 million articles, so we can deal with a few million topics and their content, and we can deal with a few hundred language renderers. And this allows now suddenly to make all the knowledge of Wikipedia accessible in many, many more languages than it was before.
Of course, that brings up questions for people who have been editing Wikipedia and know that, Wikipedians don't always agree on the facts even. And, you would take some hot topics and they would be completely different in different languages. So how is that going to work exactly? I'm assuming that at the beginning, we would simply structure the things that we agree upon, or there would be some way to, just like in Wikidata, to capture the multi-faceted various versions of the truth as it's being captured by different volunteers. But it does sound complex in a sense.
Yes. So this is a very, very difficult question, and I have multiple answers for that. So one answer is that we're not replacing the current Wikipedias. So if there is a topic that is particularly relevant for a given language, I would completely expect that in this language, well, they won't actually take the content from abstract Wikipedia and turn it into language, but rather they will still continue to have a handwritten article on this topic. Because the handwritten articles will, for a long time and probably for forever, be more nuanced, still be more expressive than what we can do in abstract Wikipedia, and capture more details than what we will have in the common knowledge base. But this also means that you are freeing up the local communities to work on the topics that they actually really care about. There are a lot of topics that a lot of cultures or languages, but they don't have a specific point of view on it. So they can just take the content from abstract Wikipedia and say, okay, that's good, let's just take it. I mean, if it's for cities from faraway places that are not related to this language, or about information about dinosaur species, or about exoplanets, all of these things, you don't have to take care of it. You can take just the articles about elements and you have them. And then you can focus on the pieces that are particularly important for a given culture, for a given language, and write those by hand. And just override whatever would come from abstract Wikipedia. You don't have to take this stuff from abstract Wikipedia. It's an offer for those places where you don't have content. And you say, okay, well, if we don't have our own article, let's just take the one from abstract Wikipedia. And then we can focus on the ones where we do have a specific point of view and they want to represent it. So this is one answer to this question. A different answer to this question is, and I think both of them are right answers, and we will see how exactly the interplay between the communities will happen. I don't think that the language should be the delineator between different points of view. I think in Wikipedia, we should always represent all relevant points of view on a specific topic in every language. I would be, let's take something historical, right? Let's say on the, okay, let's say we have two different articles in German and in Italian on pizza. And let's claim that the Germans have a very different view on pizza than the Italians have. I wouldn't want that the German article only represents the German view on pizza and the Italian article represents only the Italian view on pizza, but I would prefer if the German article would describe the German view on pizza, but then say the Italians have a very different view on pizza and this is like this. Because I want, as a German reader, I want to have actually access to both of those points of view. And I would prefer if the Italian point of view would also do this. They might have like a different ordering of the information. They might have a different emphasis in information. But I would like to see what are actually the German and the Italian view on pizza, and to have access to both of them. And then the French article would describe, yeah, well, the Germans think this, the Italians think that, and this is what they think about pizza. We don't have actually our own point of view. It's fine. But in every language, we should have access to all of these points of view. It would be very sad for me if the German article would only have the German view and not even mention that the Italians have a different point of view. It would even say that this is a German view of pizza. So say, pizza is this, and that's it. And that's it. And I think this would be a very incomplete view of the world. And we see that actually, for example, the English Wikipedia. We don't have an English Wikipedia for the United Kingdom and an English Wikipedia. Actually, even we don't have an English Wikipedia for the people in England, one for the people in Scotland, one for the people in the US, and one for the people in Canada, and one for the people in India, right? But we have one English Wikipedia, and we say, okay, well, this is for this is for all the people who read and can write in English, and it doesn't matter where they are, even though obviously the point of view between the UK and the US might be very different on certain things. But we don't split the Wikipedia there, but rather we say, well, in this article, here's the US view on things, here's the UK view on things, and we describe those different things. For English, so it seems it's okay that we have like different, but so the same thing for Spanish or for Portuguese. You know, we don't have a Latin American Wikipedia and in Spanish, and a Spanish Wikipedia in Spanish, but we have one Wikipedia in Spanish. So language is kind of a arbitrary barrier that happens to be a very practical one as long as you can't easily go from one language to the other. Abstract Wikipedia is trying to pull this barrier down, or even maybe pull it away if possible, and to make everyone be exposed to all of those different points of view, no matter what language they are prevalent in, no matter what language you can, because I think you can learn from all of these different points of view. And you don't have to agree with them, but you should be able to see them, you should be able to learn about them, you should be able that they are there, and to help you understand each other. And I wouldn't want to have language as a barrier to understanding different points of view. So this is my second answer. So the first one was, well, you can just override the common view, but the second answer really is, I think that language shouldn't be the barrier between these things. We should actually express them in different, the different points of view in any language and make it accessible to everyone. And this is also partially because I come from Wikipedia, the Croatian Wikipedia, which did have some trouble with that. There was, and this has been exhaustively investigated. There has been a time in the Croatian Wikipedia where the community was basically captured by a right-wing point of view, and this had strong influence on a lot of the content in the Croatian Wikipedia. And I'm not saying that abstract Wikipedia would make that impossible. It certainly wouldn't. But you would always have the ability to see, okay, I see the article here about, you know, this event during World War II in the Croatian Wikipedia, and then just one click away is, what does abstract Wikipedia say about this in Croatian? And then you can see, oh wait, this looks very different. It is still, you know, effort to actually go and see these things in the different languages, sure. But it's much, much easier than it would be today, where you would go to a language that you maybe don't speak and then use something like Google Translate, and who knows how good the quality of the translation is and so on. So with abstract Wikipedia, I hope that we can make it more visible that, oh, maybe something going on. Maybe the point of view in your local Wikipedia is not necessarily shared across other languages. And the hope is, just as with everything that is being co-created in the Wikimedia universe, that by having more contributors, more eyeballs, that the result will be less biased and more balanced than it would be in a smaller community. And the smaller language communities always run a higher risk of being captured than do the big language communities, just because there are fewer people there, and there are fewer people who can actually contribute there. So the hope is that then abstract Wikipedia will, just by the nature of being accessible to everyone, and everyone can contribute to it, and it will have more contributors, more eyeballs, more attention, and that the risk of ideological capture is lower than for any of the individual language communities.
And not only that, the information would be more, as you said, balanced and less biased, but hopefully, as you said, I'm just stressing, it would free human volunteers to kind of focus on specific things that machines can't do, and but all the bits that machines can do will be helping. I mean, machines will be helping humans in a sense more, to kind of maintain information in different languages, which is not happening to the extent that we want right now.
Yeah.
So that's a huge endeavor, and I'm wondering if you can share where we are in the process of actually developing these functions and then integrating it into Wikidata. I mean, how does the whole process, the whole flow, if you can say something about the flow.
So we are currently mostly working on getting Wikifunctions ready for launch. Wikifunctions is now in a place where we can actually evaluate functions, we can run them. We have support for several programming languages. You can write functions in JavaScript, you can write them in Python. The goal is that we can have even support for more programming languages later. We have something that we call composition, where you can take smaller, simpler functions and pull them together to make more complex things. One of the things why we're doing this is, so there have been traditionally a number of barriers towards programming. One barrier has been that basically all programming languages, there are a few exceptions, but most programming languages out there in the world are based on English. And which means that in order to program, you first have to learn some basic English. And this has been recognized and identified as a blocker and a hurdle for a lot of people to contribute to coding. We want to remove this. We want Wikifunctions to be a place where you can create functions without ever have to write a single word or read a single word of English. So we want to remove this barrier. The second barrier is that basically every introduction to coding, every learning of coding starts with math. They start with examples in the math space, and I've been doing actually the same thing when I was introducing Wikifunctions. Before, I was using examples coming from the worlds of mathematics. And by now, we actually learned, there's been research published in Nature that shows that there is actually no correlation between math capability and natural language and programming capability. Not at all. You don't have to know any math in order to be a good programmer. But almost every course around programming is starting, with examples in mathematics. And there's a simple example for that. There's a simple reason for that, because people who already have a good grasp of mathematics, for them it's easy, to write functions about mathematics, because they're actually very simple once you are sold to this world of mathematics. But you don't have to. And in fact, there has been strong indicators that there's a very strong correlation between natural language aptitude and programming capabilities, which means that the people who are really good with language are actually also likely really good with programming. But the thing is that most people who think who are good in language don't think that they're good at programming. They think they're not good because they're not good at math, and this has been like an additional barrier. We want to pull this barrier away too. So our goal is really to reach people who haven't been programmers before in order to create all these functions that we will need in order to create natural language.
How does it look like, Denny? Can you already show something, or is it too prototype and not ready to be seen just yet?
I think it's super prototype still. I can see a look if I have some. I think our prototypes really are not yet in the shape to be shown. They should be very close to it, but I'm very sad that it's not there yet. But I don't think our prototypes are yet in the shape where we can actually display them. And we did have some initial success with user tests. So it's an almost funny story. So we were talking with people who are already Wikipedians, and we were talking about them about Wikifunctions, and a lot of them were saying, "Oh, I'm not a developer. I don't need to understand how exactly it works, but they will be happy to use it." I was like, "Okay, well, that's good enough." And then just like 2 weeks later, we were publishing one prototype, and then exactly one of the users who was saying they won't be using this. So one of the things that we did there was we showed an implementation of a morphological function, basically taking an English noun and how to create the English plural out of it, which is usually just adding an S, but you know, English has a lot of exceptions and different rules, so they were implementing some of those. The users who were previously saying, "Oh, they don't need to code," you know, they're just copy and pasting the solution and using it for French and implementing there successfully, like creating tests, creating an implementation, and all of these things. And my heart was really opening up, because I was like, this is the same person who just said 2 weeks ago they don't need to do any coding ever, and they just managed the whole workflow and did everything. And this like gave me some hope that we are on the right track, you know. And I hope that people won't even realize that they are coding when they're creating those functions. That they will just take in the language blocks and pulling them together and building those functions necessary for natural language generation without having those barriers of needing to speak English, those barriers of needing to understand math, but rather they can somehow work those out and create those functions. Because I think, you know, those unicorns who know how to code, know language sufficiently well to actually create those functions, who know grammar of it. Most people don't know the grammar of the language explicitly, right? They just have an implicit understanding of the grammar. So people who know grammar well, know how to code, and have enough time to actually support our project, because, you know, people with those two capabilities are often in high demand anyway. So, you know, those unicorns are rare. So I really hope that with Wikifunctions we can remove all those barriers in order to have many more people contributed, in order to create this library of natural language generation functions for 400 languages. I think this is very important for us to actually get right. And I'm really, really sorry that I'm not able to show you demos yet that show where we are. A lot of this stuff is just still in development and in design.
Oh, don't worry about that. Something to look forward to next year, I guess.
Oh, I very much hope so.
But I'm kind of curious if you can share, you know, anyone who, even without knowing how to code, which most of my students don't, and I know just a bit of, even without understanding any of it, and just, you know, living in the 21st century and hearing, you know, or being available to having tools like Siri and Alexa, and hearing all these buzzwords from recent years of machine learning and, you know, other AI developments. So I'm kind of curious to hear you, if you're willing to say something about where all of that work fits into the larger things happening on the web. Is it like, to some extent, it sounds like a different route to get to the same thing. In other senses, it sounds like this is an ecosystem, and it all kind of, even if it's a different route, it might feed into other things that are happening. But this is my uneducated understanding, and I would love for you to kind of give us some more perspective on the connection to what's happening generally.
Yeah, so the Wikifunctions and apps like Wikipedia are, as you have pointed out, very much against the current trends in computer science. They're not based on machine learning. They're not based on all these on all the AI work, which has been a huge success in the last few years, right? And you could very much ask, like, why am I not building on those like huge successes? And there are two answers to that, really. The first answer is that a lot of the machine learning results are hard to inspect and understand. The results of them feel like magic, and they often are like a little bit magical in the sense that we actually don't know why they give those answers. So this also means that if you see, you can't really predict those answers that come out of the system. You can't really know how exactly it looks. It's more like, oh, let's try it out and see what comes out. And which is a great approach, for example, if you know, create 10 different texts or 10 different images from one of those systems, and then you choose the ones that you like. That's perfect. But for an encyclopedia, it's like, well, you want to learn about a specific topic. You don't know in advance already what's correct and what's not. You certainly don't want it to make up, you don't want a system that makes up 10 biographies of Marie Curie and then you choose one of those that you like most. That's not how an encyclopedia works. And also, they're hard to edit and correct. If there's a mistake, what do you do in a machine learning system? It's like, oh, well, I don't like this. You can mark it up as a mistake. And then you can try to find more data and to retrain the system and hope the mistake will go away. And that you didn't introduce other mistakes on the time. I mean, this is okay as a process if you're a company and where you have actually, you know, people working on these systems like this. But if you have volunteer contributors, you want to be extremely careful about their valuable time. You want to make sure that the edits that they make actually stick. You want to make sure that they can figure out how do they improve a thing. How there's something wrong, they should be able to know which button to press and what things to change in order to fix the issue. And they should be confident that when they click publish, they actually have fixed the issue. And then they maybe have a preview and see, okay, that's good. And go fix it. With machine learning system, we are not in the space that we actually can provide such an experience, that the people can say, oh, no, this is wrong, let's click edit, let's fix it and have this fixed, and be confident this will stay now like this unless some other human comes in and edits it. So there are a lot of workflows that ML systems don't really help us with yet. Having said that, if you take a step back, what is ML actually doing? ML is, or machine learning, what is actually doing? So machine learning is actually trying to, based on data, to automatically learn code that produces the output that is represented by the data. So it's not magic at all, right? It's just actually, we have a computer that is given enough data, is trying to write a function, to write code that actually produces something that fits this data. And then you give negative examples and it tries to avoid to get those negative examples. So it's actually just automatic programming. So in some way, what we're doing in Wikifunctions is we're saying, okay, well, here we will also have like test example. We say like this function should give the following results and it should not have the following. Now you could just actually create a machine learning mechanism that, giving a specification of a function, tries to automatically learn the implementation of the function. And so we could have users who come in Wikifunctions and say, okay, well, to give one example, these are examples of singulars and plurals. Here you have like 10 examples. Now try to find an automatic, now try to find some function that actually creates those results. And this can be completely done in machine learning. There's no reason that a human has actually to write the implementation. We can have a machine create the implementation, deploy it in Wikifunctions, and then have humans see, oh yeah, that looks good, and then we combine this result with the other results and build higher level on top. And you can do this with all the functions. So in many ways, actually, you know, you can have Wikifunctions and actually OpenAI has developed this, this very strong machine model, which does exactly this kind of thing. It's called Copilot, for example. So you have a developer working inside of the development environment. They just describe the function that they want to have, and OpenAI offers, suggests you an implementation of it. You say, oh, that looks good, and you just take it, and so on. And the same thing we can do actually in Wikifunctions too. We can have, and specifying the function that you want is in Wikifunctions, we have always considered this to be a workflow which is independent from providing the implementation for that function. So we hope that in Wikifunctions we will get to a space where, you know, people say what functions they need, what functions they want, they specify examples of how this turn out. And then we can have either other people coming in and implementing it, or have a machine actually look at those specifications and say, oh, I can do that, and makes the suggestions of how this could look like. And then we can think of a feedback loop where people then say, oh yeah, that looks good. Let's try a few more examples. Ah, no, this was a mistake. Go back and give me something better. Or yeah, no, this is good. Let's keep this for now. And then we can have more tests later, and when something's wrong, then we can go in and start debugging what's going on and have maybe the machine be replaced or improved or whatever. But there's a lot of spaces like these where we can combine machine learning results inside this world of an editable and understandable wiki, which still allows the community to actually use those results and combine them in a way that is predictable, in a way that allows them to actually click on edit and fix things, and doesn't have to be completely left to the magic of the machine and hope that things will improve, but rather to make it understandable, predictable, and editable for the community.
Well, you were talking, and all I could think about was the Depict game, the Depict Wikidata game. I mean, it's almost the same thing, but the higher level of it sounds like it. I mean, in that collaboration with the Met, they used machine learning to kind of create it for the machine to learn what it can from the existing metadata and make suggestions that then, you know, humans were able to make the final judgment. But it was in a very simple way. And I was thinking of you talking about, you know, removing all the obstacles and all the very high thresholds that we still have today. And this sounds like a really important step in that direction. So I'm really happy actually to hear that answer from you. I'll say one more thing, in that when you spoke, all it did is kind of bring more questions and more questions to my mind. But I'll pause here because I want to invite everyone who's listening to kind of participate in our live portion of this meeting. And I didn't say at the beginning, but we're pre-recording this portion for my students to watch, but also for the larger community who's interested. And everyone is welcome to join us on the 30th of May, where you will come live to the session and answer different questions. So this is a good time, I guess, I hope that we kind of pique the imagination, or it was interesting enough for people to maybe come up with some more questions and some more things that they want to learn from you. And then they are welcome to either pre-send questions or actually participate live. So with that, we'll keep a list of questions coming from the community. And thank you so much for this talk and all these explanations. And I look forward to hearing the answers to all the questions that the students and the general community will come up with. But before we part, I do want to give you just a chance to maybe conclude and share anything else that you want as a base for our live meeting in a few weeks.
I want to say thank you for inviting me, and I also want to say thank you for everyone who is listening to this. And I'm very much looking forward to your questions and to hear them. I had the good luck of being invited 2 times before by Shani, and it was always inspiring to listen to the students and to listen to the community voices, to ask questions and to have to think about those, because the questions were often very on point and rarely like, oh yeah, no, this is easy to answer like here. This is always like, oh, yeah, very good question. So how do we answer that? So they always cause more thought, and they often lead to improvements in the overall system and how to, what exactly to build in order to make it really useful for, well, for the world at large and the community. So so thank you for listening. Thank you for having me, and I'm very much looking forward to hear your questions and to try to answer them on May 30th.
Thank you so much. And again, thank you for being so open about your work and willing to answer these questions. I know it's not easy always to kind of get these ricochets in real time and kind of trying to accommodate our very, very diverse community. So we appreciate your work and trying to push the boundaries of what is possible. And we'll see you on the 30th. So thank you, and looking forward to seeing some people from the community as well.
The same. Thank you so much.
Thank you.